stoichiometry of solution. Okay, so these are the three questions for each of them. Now, before I continue, where is the solution? Solution is made up of what? The solution made up of the solvent, made up of the solute and what, and the solvent, right? Solute and the solvent. Okay, yes. So solution is made up of solute and solvent. You know that solute usually is what usually dissolve in the solvent. Okay, yes. Now let's move to molarity. Okay, molarity presented by a capital letter M. Now, what is molarity? Molarity is number of mole of solute dissolving what in okay, it's number of mole of solute per volume of solution in liter. Okay, yes, the number of moles of the solute divided by the volume of the solution. The volume must be in liter. It's very important. It should not be in milliliter. If it's milliliter, you convert it to liter. Okay, so that is for molarity. Okay, yes, number of moles of the solute divided by the volume of the solution in liter. Then while molality, small letter m, is equals to number of mole of the solute divided by the mass of the solvent. If you look at molarity, it was number of mole of the solute divided by volume of the solution in liter. But in molality, it's because number of mole of solute divided by the mass of what? Of the solvent in what? In kg. Let's say that if the mass of the solvent, if it's in gram, convert it to kilogram by, by dividing by 1000. Okay, yes. Then normality. Normality. Now, I'll give you guys two formulas to calculate for normality, which is very important. Okay, normality is equals to molarity times n. N is known as we can call n factor. Okay, n depends on the type of reaction. Okay, for acid, n is equals the number of hydrogen ion. Let's say we are dealing with H2SO4, right? Yes. Now, if they say calculate for the normality of H2SO4, for example, you will need to know the molarity first, which is number of mole divided by volume of solution in liter, then times n. Now, n in n, this is an acid. I say n depends on the type of reaction. If it's for acid, n is the number is number of hydrogen ion. Now, for this H2SO4, how many replaceable hydrogen ions in H2SO4 is 2. So if we are dealing with acid like H2SO4, N will be 2, right? If we are dealing with hydrochloric acid, N will be what? N will be 1. If we are dealing with HNO3, N will be what? N will still be 1 because HNO3 has one hydrogen replaceable hydrogen ion. Okay, if we are doing H2SO4, we do what? The N will be what? 2. Now, N cancel, it depends on the type of reaction. For acid, it is N equals the number of H plus. For base, N equals the number of OH. Like for example, if we are dealing with and sodium hydroxide, N will be what? N will be, how many OH is here? 1, right? Yes. But if OH is 3 or 2, N will be what? N will be 2. If OH is in the base, like for example, CaCOH2. Now, Ca bracket open, OH bracket close 2, N will be what? Will be 2 because OH is 2, right? Yes. So N depends on the type of reaction. For acid, N equals the number of H plus. For base, N equals the number of OH minus. Then for redox reaction, N equals the number of electron lost or gained. So it depends on the type of reaction. Okay, so this is one formula to calculate for normality. Okay, yes, which is normality is equals to molarity times n. N depends on the type of reaction. For acid, N is number of H plus. For base, N is number of OH minus. For redox reaction, N equals the number of electron lost or gain. Now, another formula to calculate for normality is that normality is equals to number of equivalent weight divided by volume in liter. This is very important. Okay, now what is this equivalent weight? Number of equivalent weight. Now, to look for number of equivalent, this part is very important. It's very important because we can in this last question we use both formulas to get our answer. Number of equivalent weight divided by volume in liter. Okay, now what is number of equivalent weight? Number of equivalent weight equals to the mass divided by equivalent mass. Okay, now what is what is this equivalent mass? Equivalent mass is is equals to number of n is equals to molar mass divided by n factor. Remember, I told you guys that n depends on for acid, n is the number of H plus, for base is OH, number of OH minus, right? Yes. So now let's solve the very first question for molarity. So let me just clean this part and solve it here. Okay, so I said calculate the molarity of a solution prepared by dissolving 11.5 gram of solid NaOH in enough water to make 1.50 liter of solution. Okay, now we are looking for molarity of what? Okay, now normally molarity is equals to number of mole of solute divided by the um divided by volume of the solution, right? Yes. Now, what is the solute here? In this, the solute is what? Prepared by dissolving. Remember, solute is what usually is one that usually dissolve, right, in the solvent. So dissolving, this the solute is NaOH, right? This is the gram of NaOH. Remember, now molarity is equal to the number of mole of solute. So in this question, they gave us gram. 11.5 gram. So we need to look at number of mole of NaOH, right? How do we look at number of mole? N is equals to giving mass over molar mass. What is giving mass of NaOH is 11.5, right? What molar mass of NaOH? Molar mass of NaOH, I'm coming. That sodium is 23, oxygen is 16, then okay, it's 40. Okay, so 11.5 divided 40 is what? Is 0 point. So the number of mole of sodium hydroxide is number of mole is 0.2875. Okay, 0.2875. Now where is the volume of the solution? In enough water to make 1.50 liter of solution. Remember, it must be in liter. So the volume of the solution is 1.50 liter, right? So let's divide it. Divide 1.50 divide 1.50 liter. So give us the molarity is what? 0.191. Okay, so it's very easy. So just know the number of what you just did. Calculate the number of mole. When you get number of mole divided by the volume of the solution, you get the molarity. Now for question 2, let's say you calculate for what? Molality, right? Yes. Molality is number of mole of solid divided by the mass of solvent in kg in kilogram. Remember, in kilogram, and it is solvent, not solute. So that is the molality. So we're looking for molality, right? Number of mole of the solute. Now, what is the solute? Solute is one that is already dissolved. Now, what is solvent? Let's look at what is the molality of a solution prepared by dissolving 20 gram of iodine. So iodine is what? Is a solute, okay, in 150 gram of tetrachloromethane. Okay, what am I having? Is this tetrachloromethane? Yeah, tetrachloromethane. So this is solvent, this is solute. Remember, the mass of the solvent must be in kg. Now, but this mass of this solvent here is in gram. So how are we going to do it? To convert from gram to kilogram, divide by what? By 1000. Right? So we need to convert this one to kilogram by dividing this from gram to kilogram. 150 gram divided by 1000 to give us 0.15. So the mass of the solvent is what? Is 0.15. Now, what about the mole of the solute? Now let's look for the mole of the solute using what? Number of mole is equals to what? Remember, molality is equal to number of mole of solute divided by mass of the solvent. This in kg, this is mass of the solvent in kg. Now let's look at number of mole of the solute. The solute is iodine, right? Solute is one that usually dissolve, okay, in the solvent. So the solute is iodine. Now what is giving mass of iodine is 20, right? Yes, divided by molar mass of iodine. Molar mass of iodine is what? 254. 254. So if you divide it, 20 divide 254 will give us 0.0787. So divided by 0.15, okay, we get what? We get 0.524. So this is the mole. This is the molality of the solution. It's very easy. Number of mole of the solute. Solute is one actually dissolved divided by the mass of the solvent in kg. Okay, so let's do the last part, normality. Okay. So let's do the last part. Um, Normality. Okay. Now, what is normality? They say a solution of H2SO4 contains 86 grams of H2SO4 per liter of solution. Calculate the normality of this solution. It's very easy. Normality is equals to what? Molarity times N. Now, what is molarity? Molarity is what we know that molarity is equals to number of moles of solute divided by what? Volume of solution in liter, right? Then times this n. N is what? N. I said n depends on what? If it's an acid, right? For acid, n equals the number of H plus. Now we are dealing with H2, H2SO4. H2SO4 has how many H? Is 2, so n will be 2, right? Now let's look for number of mole of H2SO4. We divide this by what? The volume of the solution in liter. So equals to n over. Now number of mole of H2SO4. Number of mole is equals to given mass over molar mass. Now what is given mass of H2SO4? 86. What is molar mass of H2SO4? 98. So 86, I'm coming. 86 going to 98, divided into 98 will give us 0.8877, 0.8775. Okay, now what is the volume of the solution in liter? If you look at it, the volume of the solution in liter, the solution of H2SO4 contains 86 grams of H2SO4 per liter. 86 grams per liter. It means that 86 divided by what? It means that 86 grams divided by what? 1 liter. If you do this thing, 86 grams divided by 1 liter will give you 86 grams divided by liter. So the same thing. So therefore liter is 1. Okay. So the volume, rather, the volume of solution is 1. Okay, per liter there is 1. Okay, 1 liter. Okay. So the volume of solution is in liter is 1. Then times, don't forget this 2. If we do it times 2, when we multiply it, our normality is 1.755. Okay, so this is normality. So this is one way. Now let's see do the other way. How are we going to do it? The other way, they said to get the other way, normality is equal to number of equivalent weights divided by volume in liter. Okay, we all know that the volume in liter is already 1, right? Per liter is already 1. Now, but what about number of equivalent weight? What is number of equivalent weight? Number this is number of equivalent weight now. Number of equivalent weight is equal to the mass of the substance divided by equivalent mass, right? Right? Yes. Now what is equivalent mass? Equivalent mass is what? Molar mass divided n factor. Now what is molar mass of H2SO4 is 98. N factor, I told you guys, n factor is depending on the type of reaction. For acid, the n factor is equal to the number of H plus. So H2SO4, number, how many H plus in H2SO4 is 2. So 98 divided to give us 46. I mean, no, 49. Right? 98 divided to 49, right? Yes, 49. So our equivalent, the molar mass is 90 divided by n factor, we get 49, right? So our equivalent mass is what? 49. Now, number of equivalent weight is equal to mass of equivalent mass. So equivalent mass is already 49. Then the mass of this guy is 86, right? 86 going to 86 divide 49. 86 divided 49 is I'm coming. 86 divided 49 is 1.755. Okay. So the mass is 86. Equivalent mass. You know how we got equivalent mass? Equivalent mass is molar mass divided by n factor. So we got the equivalent mass to be 49. We got the mass of the substance to be 86. If you divide again 1.77, right? Yes. Now this 1.77 is our what? Is our number of equivalent weight. So remember, n is equal to number of equivalent weight divided by volume in liter. Our number of equivalent weight is what? Is 1.755, right? Yes. So number of equivalent weight is 1.755 divided by what? Not volume in liter. Liter is 1, right? So if you divide it, you still get 1.755. So that is the other way to get for normality. It's two way. The first way, molarity times n, which is n factor. N depending on if it's a base, n will be number of OH. If it's a acid, n will be number of H plus. So yes, if you use this other method, number of equivalent weight is divided by volume in liter. But equivalent weight is equal to mass divided by Number of equivalent weights is equals to mass divided by equivalent mass. So the mass is 86, right? Equivalent weight. Look, equivalent weight is molar mass divided by n factor, right? When we talk about the equivalent weight, we got 49. Then the mass is 86. We divide it to get number of equivalent.